Let's take a look at Gaussian Jordan elimination on a TI-89 calculator. And bring up my website. This is www.mathheals.com. You can go to the Graphing Calculators link here. I'll eventually rename it Graphing Calculator/Technology. And then this brings this page up, and I'm going through different subjects, creating videos for it. I'm working on college algebra now. And these are all the different topics in college algebra where you can use a graphing calculator. And I'm working my way through all the different calculators. So you can come here and you can watch different videos. Now, if you're struggling in college algebra, you need some extra help, there's math class information right here. If I click that, then you can click college algebra, and you can watch full lecture videos out here. Like for linear equations, rational equations. If you want to watch that, you just watch this YouTube video. Don't watch WebEx. I need to eventually remove those. And WebEx was before I learned how to do it from YouTube. Okay. Let's take a look at this one right here. And so we got this problem. Okay, so we got x plus y minus 2z is equal to 3. 4x minus 2y plus z is equal to 9. And 5x minus y plus 3z is equal to 16. Okay, let me write down the matrix. Goes with this. We got 1, 1, negative 2, 3, 4, negative 2, 1, 9, 5, negative 1, 3, 16. Now let me show you the fast way first. I'll show you how to use RREF on your calculator to quickly get your answer, and then we're going to go through it step by step. So if you need to do it step by step, you'll have how you can use the calculator to help you with it. I want to go input this matrix. So I'm going to go press my, well, let me do an up arrow and press backspace over and over, clean all those out. There we go. Now I'm going to press apps. Now we want to go into the data matrix editor, and there's a 6 in front of it, so I'll press 6. And you'll probably do new. If you do 3 for new, then it comes up with type, and you do a right arrow, and then we want to choose matrix. So I'll choose 2 for matrix. I'm a down arrow to the variable name, and I want to put A in. The alpha lock should already be on, so all I have to do is press my A, the equals. You see that up here. Now if I do a down arrow, I want to shut the alpha off, so I press alpha 1 time. And this is number of rows. We got 3 rows, so I do 3, down arrow, and then number of columns, which is 4, and down arrow. And then if I press enter, I'm going to get an error. It says variable flash application in use. I already got A defined, but in yours it should come up with the matrix, unless you've already used A. I'm going to press escape, and I'll press escape again. If you've already defined A, you already created A, what you need to do is go under your apps, choose data matrix editor, do 6, choose 2 for open, and when it comes up with type, you do a right arrow, and you want to choose 2 for matrix. I'll down arrow twice, and if you got the variable here, you can do a right arrow, and this will have a list of all the different matrices you've got defined. Now I only have A, so it's kind of boring, but now if I press enter on that, and then press enter again, it'll bring up my matrix. Now if your matrix is not the right size, you can resize it by going into your utility menu. So to get to F6, I do second F1. And you see number 6 is Resized Matrix, so I press 6. And rows 3, so I do 3, down arrow, columns is 4, down arrow, and then I press enter. Now mine was already set that way, so it didn't really matter. But if you had a different size, that's how you'd resize it. Now we'll type in our numbers pressing enter after each one. So do 1 enter, 1 enter, negative 2, 3, 4, negative 2, 1, 9, and 5, negative 1, 3, and 16. Okay, let me double check them all. 3, 9, 16, negative 2, 1, 3, 1, negative 2, negative 1, 1, 4, 5. Now I want to exit out, so I do Shift, Escape, and we've now input A. Well, I'm going to do REF. So I'm going to go to my math menu, so do second, 5. I want to choose 4, the numbers in front of matrix. And then I want to choose 4 again, the number in front of REF. Now I need to tell it REF of what, so I'm going to do alpha equals to get A, close parentheses, enter. Okay, let's see what we got now. So using our REF, we came up with 3, 2, 1. Came up with this. Okay, we have 3 equations, 3 variables. That means that our first 3 by 3 here should be a diagonal 1, 0, 0 else. And it is. That's what REF means. Diagonal 1, 0, 0 else. That stands for reduced row echelon form. It's actually a little bit more than that, but for purposes of what we're looking at, that's all it means. And if that's true, then your answer is the far right column. So this is going to be X, this will be Y, and this will be Z. So our answer is 3, 2, 1. The reason why this is X, Y, Z is because I put my X column here, I put my Y column, Z column. The same order you put your columns in is the order of your answers. Okay, now if all you're looking for is the answer, use REF. Don't go through the next steps I'm going to show you. But if you're in a class where you need to do the next steps, or you're just trying to understand the flow of the next steps, then you can definitely use this to help you solve problems. Okay, REF. First thing we want to do is get a 1 here. We have a 1 there, so we don't have to do anything. So we got 1, 1, negative 2, 3, 4, negative 2, 1, 9, 5, negative 1, 3, 16. Okay, so you got a 1 in the first position, and then you want to get zeros below it. That's our next goal. Now you look at your first row and you ask, what do I multiply times this 1 that then can add to 4 to get a 0 here? Well, that'd be negative 4. Negative 4 times row 1 plus row 2 will give you your new row 2. Then you ask yourself, what times the 1 that you can then add to the 5 to give you a 0 here? Well, that'd be negative 5. Negative 5 times row 1 plus row 3 gives you your new row 3. Okay, let me go ahead and do this by hand, then we'll do it on the calculator. So I got 1, 1, negative 2, 3. Negative 4 times 1 is negative 4 plus 4 is 0. Negative 4 times 1 is negative 4 plus negative 2 is negative 6. Negative 4 times negative 2 gives me 8 plus 1 is 9. Negative 4 times 3 is negative 12 plus 9 is negative 3. Okay. Negative 5 times row 1 plus row 3. So negative 5 times 1 is negative 5 plus 5 is 0. Negative 5 times 1 is negative 5 plus negative 1 is negative 6. Negative 5 times negative 2 is 10 plus 3 is 13. Negative 5 times 3 is negative 15 plus 16 is negative 1. Usually I screw up on a basic math error somewhere on these. Okay, let's do it on a calculator and check to see if I'm correct on this. Now the function we're going to be using, let me show it, and then I'll write down the setup. If I go in my matrix menu, if I do second 5 and choose 4 for matrix, and I can do an up arrow probably to get there faster. You see there's one that says row ops. If I do a right arrow, you see there's one that says m row add. That means multiply a row by a number and then add it to another row. Now there's another one we're going to use, m row. That means multiply a row by a number. So let's take a look at this. M row add. M row add. Okay, well the number we're multiplying by is negative 4, comma. You need to tell what matrix, and we stored this in A, comma, and we're multiplying it by row 1. So do 1, comma, and we're adding it to row 2. Okay, this one will be M row add, and we're multiplying it by -5, and working with matrix A, and we're multiplying it times row 1 again, and we're adding it to row 3. Okay, let's see what these give us. So I'm going to choose the last one, M row add, and I'll put in -4, comma, A, so I do alpha equals for the A, and then I do comma, and then 1, comma, 2, closing parentheses, and enter. Let's see how that compares. 0, -69, -3. That's good. Now, when we're doing this, we didn't actually store it anywhere. A is still like it was. In order for this to be stored, I can press a right arrow key here, and after I got that, then I'll press my store button, and then I'll do alpha equals to store it back into A. And now press enter. And now this is our new A. We just wiped out row 2. Well, let's do this next one. So now this is already up. I'm going to clear it. I'm going to go through the menus, even though it's painful, just to really emphasize where it's at. Okay, so I'm going to do my second 5 to go to my math. I want to choose 4 for matrix, and I want up arrow to J, and then I'll right arrow, and then I want to choose number 4, M row add. So do 4 again, and then I'll put a -5, comma, A, which is alpha equals, comma, 1, comma, 3. Close parentheses and enter. Let's see how that looks. 0, -6, 13, 1. Doesn't look like I made a basic math error. That's good. Now I'm going to right arrow on that, and I'll press store, and then I'll do alpha equals to put it into A, and then press enter. Okay. Now what we want then, working our way down. We got a 1 here, 0's below it. Next place is we want to get a 1 here. So you have to think, well, what can I multiply by this row to give me a 1 there? Well, if I take -1/6 times row 2, that'll give us our new row 3. Okay, well, let me do that by hand. 1, 1, -2, 3, 0, wait a minute. That's a new row 3. Let's try it again. Row 2. The last row remains as is. Okay, -1/6 times 0, 0. -1/6 times -6 gives us a +1. -1/6 times 9 gives us -9/6, or -3/2. And -1/6 times -3 gives us a +3/6, or 1/2. Okay. Well, let me press clear there. If I go into my second 5 for the math, choose 4 for matrix, and then up arrow, you'll get to row ops, and you can press right arrow. And we want M row. Multiply the row by a number. So I'll do 3, the number's in front of it. And we're going to multiply it by -1/6. So -1 divided by 6, comma, and then I'm going to choose the matrix. So I do alpha equals for A, comma, and we have to choose which row. We're multiplying it by row 2. So I do 2 and then enter. Or close parentheses and then enter. Yeah, that looks promising. Okay, so let me write down what I just did. M row, -1/6, and working with matrix A, and I multiplied it times row 2. Okay, working our way down. We're getting 1 here, 0's below it. We get a 1 here, we get 0's below it. So I'm going to try to get a 0 here. So we think, what can we multiply times row 2? Because this is now our pivot number. This is our pivot, and we're getting 0's below it. So you think, what can I multiply times this 1 that then can add -6 to give me a 0 here? Well, that'd be 6. So 6 times row 2, and we'll add that to row 3, and that's going to give us our new row 3. Okay, how that'd look like on the TI-89 is m row add, and then we'll do 6, and working with matrix A, we're multiplying it times row 2, and then adding it to row 3. Always, your matrix here that's on at the end is always the one that goes right here. So row 3, 3 here. Now let me do it by hand, and then I'll do it on calculator. Okay, so we got 1, 1, -2, 3, 0, 1, -3/2, 1/2. So 6 times row 2, 6 times 0, 0 plus 0, 0. 6 times 1 is 6 plus -6 is 0. 6 times -3/2 is -18/2, which is -9 plus 13 is 4. 6 times 1/2 is 6/2, which is 3 plus 1 is 4. Well, let's go do this on our calculator. So we'll do an m row add. Now you can do an up arrow and keep up arrowing until you get to the one you want. So let me press enter on that. Now do a backspace to clean out that store. I don't want to store it yet. And then I can come here and do my arrow keys, backspace, and we've got 6, A, and then backspace 2. There we go. Let's see what that looks like. Press enter. And must have missed something. 6 times A, row 2. I didn't store this one off, did I, when I multiplied it by -1/6? Okay, let me do an up arrow. That's got to be here somewhere. There. Oops. So I'll do enter on that. Let me do an enter again, see what it looks like. Okay. Now I want to store that, so I'll do a right arrow, and I'll do store, and then alpha equals, and press enter. Okay, that looks better. I just stored that in there. So now I'm going to do an up arrow and look for the one I just tried to enter. Find it eventually. Okay, that one. So press enter on that, and now let me press enter again. 0044. Okay, that looks promising. I got to remember to store it this time though, so I'm going to right arrow, and I'll do a store, and I'll do alpha equals for A, and press enter. So that's what we got here. Okay, working our way down. Diagonal 1, so 1 here, 1 here. Our next one is to get a 1 here. So you think, what can I multiply times this row to get a 1 there? Well, if I take 1/4 times row 3, that's going to give us our new row 3. So we've got 1, 1, -2, 3, 0, 1, -3/2, 1/2. 1/4 times 0, 0. 1/4 times 0, 0. 1/4 times 4 is 1. 1/4 times 4 is 1. Well, let's go check this on the calculator. To multiply this, we're going to take m times our row, multiply times our row, and we got 1/4. We're working with matrix A, and I'm working with row 3. So that's how we're going to enter it in. Okay, so I would do a clear to clear that, and then I'll do second 5 to bring up my math menu, 4 for matrix, then up arrow, go to row ops, press your right arrow, and we want the m row, which is the third one now. And then I'll do 1 divided by 4, comma, and then alpha equals for the A, comma, 3, and then closing parentheses, and press enter. Okay, that looks promising. That looks like what we have right there. So I'm going to go ahead and store that. So I'll right arrow, put store, and then I'll do alpha equals for the A, and press enter. Okay, we just stored that then. Now this right here is REF. So this is, assuming I get my tablet to work, REF, row echelon form. So row echelon form. For purposes of what we're doing with this, row echelon form just simply means a diagonal 1, zeros below it. Now if I will put my x, y's, and z's back in, keep in mind this is your x column, your y column, and your z column, then I'm going to have x plus y minus 2z is equal to 3. I'll have y minus 3/2 z is equal to 1/2. And I'll have z is equal to 1. And then we would use backward substitution. Backward substitution means I start at the bottom here, and this one we got z is equal to 1. Then I put 1 in for z right here, and you get y minus 3/2 equals 1/2. Take negative 3/2 over, and we got 1/2 plus 3/2, which is 4/2, or 2. So we get y is equal to 2. So then I come up here, I put 1 here, I put 2 here, and then I solve for x. And that'll give us our answer. Now, I'm not happy with REF, though. I'm going to go through and do the full REF. Okay. Worked our way down, getting diagonal 1, zeros below it. Now, I'm sitting down here at this entry. Well, I'm going to go backwards now, go back up the diagonal, and I want to get zeros above each pivot point. This is my pivot point, so I want to get zeros up here. Don't hardly have room, but I think what can I multiply times 1 that I then can add to the negative 3/2 get a 0 there? Well, that'd be 3/2. So I'm going to take 3/2 times row 3 and add that to row 2, and that'll give us our new row 2. Now for this one here, I think what do I multiply times 1 that I can then add negative 2 to get a 0 there? And that'd be 2. 2 times row 3 plus row 1 gives you your new row 1. Okay. In terms of the calculator, this right here will be m row add, beginning parentheses, 2, comma, the matrix we're working with, which is A, comma, the row we're multiplying it by, which is 3, and then the row we're adding it to, which is 1. It always follows the same form as this. See how my 2 first goes there, 3 goes here, 1 goes here. Okay, and this next one then, we'll also do m row add, and I'll have 3/2, comma, A, comma, 3, comma, 2. Again, 3, 2. Well, let's do this by hand, see what it looks like. This one's 0, 0, 1, 1. Well, taking 3/2 times row 3 plus row 2. 3/2 times 0 is 0 plus 0, 0. 3/2 times 0, 0 plus 1 is 1. 3/2 times 1 is 3/2 plus negative 3/2 is 0. 3/2 times 1 is 3/2 plus 1/2 is 4/2, or 2. Then this one. We're going to take 2 times row 3 and add to row 1. 2 times 0 is 0, plus 1 is 1. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus negative 2 is 0. And 2 times 1 is 2, plus 3 is 5. Well, let's do this on the calculator and see how it looks. Try to remember to actually store this off. Okay, so I'm going to clear that, and then I'll go into my second 5, choose 4 for matrix, up arrow to row ops, then right arrow. Now I'll choose m row add, so the fourth one. And I'll do the 3/2 first. So 3 divided by 2, doesn't matter, in case you're wondering. Comma, alpha equals for the A, comma, 3, comma, 2, close parentheses, and enter. That looks good. Now we want to store that, so I'll right arrow and do store, and then I'll do alpha equals for the A and press enter. Well, we want to do the next one. So imrow add 2A31. So I'm going to clear that. I'll do second 5, choose 4 for matrix, up arrow to row ops, then right arrow, and I'm going to choose imrow add, the 4th one. Okay, so I'm going to do 2, comma, A, so I do alpha equals to get the A, comma 3, comma 2. Close parentheses, enter. Let's see what that looks like. I don't know what that looks like. Let me do alpha A, see if I stored it. Where are we at? Okay. So we just got that right there. And I'm trying to work on this row. Okay. So let's see what I got. I'm going to do an up arrow, keep up arrowing. This is the one I just entered. 2 times row 3, row 1, new row 1. A. Ah! I screwed it up. 2A3, and then I should have a 1 there. So let me press enter on that. This is why you shouldn't just automatically store it. I didn't screw up to illustrate that point. I just screwed up because I screw up occasionally. Let me press enter. This again, this preview is invaluable. I know what I want. I want to get zeros above it. I don't even have to compare it doing it by hand. I know that's what I'm looking for. Well, that looks good. So I'm going to right arrow, and I'm going to do my store, and I do alpha equals for A, and press enter. Okay. Our next pivot point. We're going back up our diagonal. So we were here, so we're going up to here. So this is our pivot point. And we want to get zeros above it. So I want to get a 0 there. Well, if we take, for this one here, if I take -1 times row 2 and add that to row 1, that's going to give us our new row 1. In terms of the TI-89, we'll do an imrow add, and then -1, comma, our matrix we're working with, which is A, comma 2, comma 1. Again, it just flows smoothly from here. So -1, A, and then 2, 1. Now let me do it by hand first. 0, 0, 1, 1, 0, 1, 0, 2. Okay, -1 times row 2. So -1 times 0, 0 plus 1 is 1. -1 times 1 is -1 plus 1 is 0. -1 times 0, 0 plus 0, 0. -1 times 2 is -2 plus 5 is 3. Now let me do that on the calculator. Okay, I'm going to clear that out. I'll do second 5, choose 4 for matrix, up arrow, row ops, press your right arrow, and I want to choose 4 for imrow add. Now put in my -1, comma, A, so I do alpha equals, comma, 2, comma, 1, close parentheses, enter. And it worked. I got it to zeros above it. So I'm going to store that. I'll do store, actually right arrow key, and then store. And then I'll do alpha equals, and enter. 3 equations, 3 variables. What you should have came up with is in your first 3 by 3, you should have a diagonal 1, zeros everywhere else. This tells you that RREF worked. So I know it worked. And if it worked, then this is going to be X, and this will be Y, and this will be Z for 3 equations, 3 variables. So our answer will be 3, 2, 1. Had to work a lot harder to get that than just initially when we just did the REF function. It just gave us the answers. So again, that's how you'd use row operations to do Gaussian Jordan elimination on a TI-89 calculator.